Okay, geometry students, in this video we are going to be looking at area and perimeter. As soon as I say that, you probably zone out a little and you say, man, this is going to be easy and boring. And I agree that it will probably be easy, but I don't think it's going to be boring. We're going to look at area and perimeter in a little different way than you're probably used to. So I think you'll find it pretty interesting. Go ahead and write this in your notes if you would, please. Your heading today is area and perimeter. Please write that down, area and perimeter, and the lesson number is 1.6. So please copy that in your notes. I would also include today's date so that you have really organized notes. Okay, so please copy this in your notes if you would. Area and perimeter, lesson 1.6, and today's date. Let's quickly review what area and perimeter are. Now this is pretty easy, so I'm not going to make you take notes on this, okay? So you're welcome to if you want to, but you don't have to take notes on what I'm about ready to say. Okay. If I have an in-ground pool like the figure to the right, and I want to put up a fence around the pool, that would be an example of perimeter, okay? Because I would start right here and I would measure the distance from here to here, then the distance from here to here, and the distance from here to here, and the distance from here to here. And then I would know the total distance, here's the key word, the total distance around the pool, and I would know how much fencing to buy. And of course that's an example of perimeter. Perimeter is finding the distance around an object, okay? Now area, if I wanted to purchase, excuse me, if I wanted to purchase a pool cover, that I could pull over the entire pool that would keep leaves out and stuff like that, that would be an example of area, okay? Because I would have some material, kind of like a blanket. Of course, it's not made out of fabric, but a blanket like that I would pull, and I would start right here at one end. I would pull it across my entire pool. And so that's an example of area because I'm finding a measurement of space, how much I need to cover a certain space within an object. Of course, the key word there is on the inside of an object. Okay, and that's area. Okay, the measurement on the inside. So a quick review of that, and now let's continue on. Okay, in your notes, I would like you to write down page 36, example 1. Please copy that in your notes right now, page 36, example 1. You are welcome to turn in your books if you want to, but it's not necessary. You do not need to copy this diagram down. In fact, the whole reason that I want you to write in your notes, page 36, example 1, is to save time in class so that you don't have to write this figure down. Plus, this problem is pretty easy, so I don't think you'll need to take notes on this, although please don't feel dumb if you choose to take notes. That's totally fine. But I want you to have written in your notes, page 36, example 1, so that you know we covered this problem, and so you can go back and look at it later if you need to when you're studying, okay? Now, I want us to find the perimeter and area of the green figure. We're going to do this two different ways, okay? So first of all, notice the green area is laid out on a grid. And I'm not sure if each block is 1 inch or 1 yard or 1 foot. We're just going to call it a unit, okay? And so one way to find the perimeter is to start right here and count around the figure. I'm going to do that really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 39, 40. So I started here and I counted all the spaces around the entire object and I got 40. So the perimeter, or the distance around the object, equals 40, and we're going to put the word units. Now listen, I know you're probably thinking, Mr. Earhart, we're in high school, but just bear with me, okay? I'm going to show you a couple things, and then we're going to move on to some more difficult problems. This is the easiest problem that we'll do here, okay? Now, another way to find the perimeter of this figure is to measure this side here, and if you were to measure this side and count down, there's 8 units. So over here, there's also 8 units, okay? And if you were to count across the bottom here, there's 6 units. And if you were to count across this little line right here, that's 2 units. And up here is 2 units. And right here is 2 units. And then if you were to count down right here on the inside, you would get a 6 and a 6. Now please trust me, if you were to add up all of these numbers, 8 plus 6 plus 8 plus 2 plus 6 plus 2 plus 6 plus 2, you would once again get 40 units. Okay, so in other words, whenever you're given a figure that is lying on a grid like this, you are welcome to count the spaces around the figure. That's finding perimeter, and that's totally fine. Another way to do it is to find the measurement of each side and then add all of those sides together. Okay, and that's pretty simple. Now let's take a look at the area of this object. Let's remember that when we find the area of an object, we're finding the measurement on the inside. So we're finding all of this right here, the measurement of the inside of this green object, okay? So there's a couple ways to do that. First of all, I could count all of these little squares. So if I did that quickly, and hopefully I'll do it right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 18, 20, 22, 24, 26, 28, 30. I think it's 36. I counted quickly. Hopefully that's correct. So there's 36 little square units. And by the way, that's why we call area square feet or square inches or square yards or square units, because you're basically finding how many little squares fit into an object, okay? So the area of this green figure is 36 square units. Now another way to find this area would be, or to find the area of this green figure, would be to divide it up into figures that we're familiar with. For example, if I were to take my red pen and go like this, and go like this, and section this rectangle off here, and I know you guys know how to do this, I'm going really fast here, and section this square off, and then this rectangle, what I could do is I could find the area of each one of these figures and then add the three together. For example, please watch this carefully. I have a rectangle right here in red that has a length of 8 right here, okay, and a width of 2 right here. Well, we're in high school math now. You guys should know from elementary school how to find the area of a rectangle. It's length times width, so the area of this rectangle is 16. Now if the area of the rectangle is 16, then this rectangle also over here, which is identical, it also has a length of 2 and a length of 8, would also have an area of 16, okay? And then this square right here, which I'm going to highlight in green, this square right here has a length of 2 and a length of 2, so 2 times 2 is 4. So there we go. This is another way to find the area of a figure. You can divide it up into figures you're familiar with, whether it be circles or triangles or rectangles, and then find the area of each one, then add them together. So 16 plus 16 is 32, plus 4 more is 36. So either way, the area is the same, 36, and that is supposed to be an S, believe it or not, square units. Okay, now this hopefully was a little bit of review. You did not need to take notes on this. I just wanted to quickly go over this. Now let's get into some more difficult, interesting, good thought, good thinking problems. Okay, copy this in your notes. Copy this right here in your notes. Consider all rectangles that have a perimeter of 24. Which of these rectangles has the greatest area? And right away you might be thinking, well, Mr. Earhart, I mean, if a rectangle has a perimeter of 24, then it's going to have the same area also, and that's not true. Okay, so let's take a look at this real quick. The best way to do this problem is to quickly put some examples up here for us to see. So take some really good notes. Here we go. And by the way, I don't care if my rectangles all look the same. That's not a big deal to me. We're not worried about that. But go ahead and draw a rectangle in your notes. And we're going to label that 1 right here and then 11 here. A 1 by 11 rectangle. Okay? And by the way, if you added all 4 sides up, you would get 24. And then, let me do one thing real quick, students. It'll save us a lot of time. Hold on one second. We can keep copying and pasting to save time. Go ahead and draw another rectangle in your notes if you would, please. And we're going to label this a 2 by 10. If you added all 4 of those sides up, you would get 24. Okay? And then we're going to write a 3 by 11 triangle. You can work ahead if you want to on this, or 3 by 9, excuse me. Okay, a 3 by 9 rectangle. And then we're going to write a 4 by 8. Let me pause. Do you see what I'm doing here? If you're a little lost, relax. Just listen to me. The perimeter of this rectangle right here is 24. The perimeter of this rectangle is 24. The perimeter of this rectangle right here is 24. The perimeter of this rectangle right here is 24. Are you sure, Mr. Earhart? Yeah, I'm definitely sure. If you add up all these sides, 4 plus 8 plus 4 plus 8, you will get 24. Okay, and we're going to continue this very quickly. We're almost done. We're not going to do this for very long. Okay, so let's put one more rectangle down here, and that's going to be a 5 by 7. And trust me, if you added up all 4 of those sides, you would get a perimeter of 24. Okay, now let's go ahead and put a rectangle over here very quickly, and we're going to put a 6 by 6, and now we're finished. Let me show you why the perimeter is 24. If I were to keep going, I would put a 7 by 5. And don't I have a 7 by 5 already right over here? Sure I do. So once we get to this point here where we start to repeat ourselves, we're going to stop. Now, for those who are really deep into math, like, well, Mr. Earhart, you forgot to include fractions. Well, I was just under the assumption we're just using integers for the perimeter, okay, or for the length, for the measurement of the length and the width. Okay, so what I've done here is I have included all of the possible rectangles that are integer measurements that have a perimeter of 24. All of these rectangles have a perimeter of 24. So it says consider all rectangles that have a perimeter of 24. Which of these rectangles has the greatest area? Well, the area of this rectangle, 1 times 11 is 11. The area of this rectangle, 2 times 10 is 20. The area of this rectangle here would be 27. The area of this rectangle here would be 32. The area of this rectangle here would be 35. And the area of this rectangle up here would be 36. So obviously, the area, the measurement of the rectangle that has a perimeter of 24 and has the greatest area is this rectangle right here, because this area is 36 and all of the other areas were smaller. Do you see what I've done here? This is what geometry is all about. Whether you like it or not, geometry is about looking at a situation using common sense and reasoning, okay? So as soon as I read this problem and it said consider all rectangles that have a perimeter of 24, I started listing out rectangles that have perimeters of 24. That's just common sense. And then I found the area of each one, and of course then I'm looking for the area that's the greatest, because it says here which of these rectangles has the greatest area. Okay? All right, I hope that made sense. Let's continue on. Okay, now let's really use our brains, okay? I want you to copy this in your notes. Write this down, please. Consider a square that has a length of 2 units and a square that has a length of 4 units. I want you to find the area and the perimeter of both squares. Then compare the perimeters and the areas and see what kind of conclusion you can come to. Okay, so here we go. Let's tackle this problem and see how we do. Here we go. First of all, let's go ahead and draw a square and then another square, and it doesn't matter if they're the same size or not, it's not a big deal. And we have a square that has a length of 2 units, so we'll go ahead and put a 2 here and a 2 here. And then it says we have a square that has a length of 4 units, so I'm going to put a 4 here and a 4 here. Now, students, all that I'm doing is I'm simply just reading the problem and doing what it says. So, consider a square that has a length of 2 units, so I drew this. Consider a square that has a length of 4 units, so I drew this right here. Okay? The next sentence in the problem says this: find the area and perimeter of both squares. Well, that's easy. The perimeter of this square would be 8 because I have 2 plus 2 plus 2 plus 2. And the area would be 4, and that's pretty easy because 2 times 2 is 4. All right. Now let's come over here to this square, and the perimeter would obviously be 16 because I have 4 plus 4 plus 4 plus 4. And the area would also be 16, kind of a coincidence there, because 4 times 4 is 16. Okay. Now, it then says to do this: compare the perimeters and areas and see what kind of conclusion you can come to. Now listen to me carefully. It is your job as a geometry student to make sure you have enough information. before you make a conclusion. Let me say that again. It is your job on your tests and your quizzes to make sure that you have enough information before you make a conclusion. So all that I asked you to do in this problem was to draw a square that had a length of 2 units and a square that had a length of 4 units. But for me, I'm not comfortable with this. I really feel like I need some more information before I can come up with a conclusion. So I'm going to go ahead and draw a couple more rectangles, and notice what I've done here. My measurement was 2 and it doubled to 4. So now I'm going to double my square. And I know this doesn't look like a square. I'm not really worried about that. Okay, we know it's supposed to be a square. So what I'm doing is I'm doubling my lengths. So I had a measurement of 2, then a measurement of 4, and now a measurement of 8. And when I do that, my perimeter over here would be 32, 8 plus 8 plus 8 plus 8, and my area would be 64. 8 times 8. Now I'm going to go ahead and draw one more square here just to really make sure I've got a good idea of what's going on. So I had a measurement of a length of 2, then it was 4, then it was 8, so I'm going to use 16 and 16, and the perimeter would be 64, 16 plus 16 plus 16 plus 16, and the area would be 256, which is 16 times 16. Now, you might be saying, Mr. Earhart, how did you know to draw some more squares? I just really wasn't satisfied with just having 2 squares and then trying to draw a conclusion about the information that I had here. Okay, so I drew a couple more, and now I'm seeing a really good pattern. Okay, so let's go ahead and draw our conclusion. I'm going to write something like this. Write this down, please. When, see if this should make total sense. Watch carefully. When the lengths I better change that. When the lengths of squares are doubled. Do you see that okay, students? When the lengths are doubled, what happens to the perimeter? The perimeter, or the perimeters, plural, the perimeters, now what happened to the perimeters? We went from an 8 to a 16, to a 32, to a 64. So to me, it looks like every single time that I double the lengths, the perimeters are also doubled. Do you see that okay? Look at it again if you need to. Whenever the lengths are doubled, the perimeter is doubled. But the areas are what? Well, let's take a look at it. I had an area of 4, then an area of 16, then an area of 64, and then an area of 256. Well, it looks like to me the areas are multiplied by 4. Okay, so there. Well, Mr. Earhart, what is really the reason we did this problem? Was a couple things I wanted you to see. Just because the length of a square or a rectangle or different objects, because their lengths are doubled, does not mean that the perimeter and the area will also both be doubled. Okay, the area is going to increase at a greater speed. By the way, many years ago you learned that if you were converting 2 square feet, you should have learned this in middle school, if you're converting 2 square feet over to square inches, do you remember you did not just take the square feet and multiply it by 12? You took the 2 square feet, you remember, you multiplied it by 12 and you multiplied it by 12 again, because when you're dealing with area, the increase is greater. And same thing down here. When I say that your areas are being multiplied by 4, that's really multiplying by what? 2 times 2. 2 and 2. So the perimeters were just multiplied by what? 2. But the areas were multiplied by 2 and then by 2 again. Now, let me sum all this up. I know I've been a little long-winded. Let me just sum all this up by saying this. In geometry, you need to be able to read a certain problem like this, come up with different scenarios, and then come to a conclusion, and then write down what your conclusion is. And that's what we did here, okay? So we're evaluating different squares, and we're we're coming up with our own drawings in which the lengths were doubled, and then we compared the perimeters and we compared the areas. Okay, not too difficult, just a good thinking problem. Okay, let's look at one more example and the video is done for the day. Okay, one more example. To save you writing this problem in your notes right here, I would not copy this problem down. It takes too much time. I would just write in your notes, page 38, example 4. Okay, just write that in your notes, page 38, example 4, and then underneath that you can take notes on this problem. Okay, let's go ahead and read this problem. It reads, you have a part-time job working at a school. You are asked to buy enough fertilizer to cover the school soccer field. The field is 50 yards wide and 100 yards long. The instructions on the fertilizer bag, say that one bag will cover 550 square feet. How many bags do you need? Now, my suggestion to you is that you first get a picture of the soccer field. So I would draw a rectangle and I would label that, and hopefully you'll draw one better than I did, and I would label that soccer field with a width of 50 yards and a length of 100 yards. Okay, now that's what I would do. All right, so I've got a good picture of this. Now I know I'm going to go to the store, and here's my bag of fertilizer down here. Here's my bag of fertilizer, and I know this bag of fertilizer that I'm going to buy is going to cover 550 square feet. Okay, so take some really good notes. I would write all of this down if I were you. Okay, I really would. And if you're working ahead, that's fine, but please check your work and make sure you're doing the problem correctly. All right, now, is it not common sense? It is to me that when they say, when the question is asked, how many bags do you need? It's common sense to me. There is no way that I can find how many bags of fertilizer I need until I know how many square feet I have. I mean, I know that one bag of fertilizer covers 550 square feet. I can see that. However, I don't know how many square feet I have on this soccer field. Now, I could take 50 times 100 and I would get 5,000, but that gives me area in square yards. And I don't want my area to be in square yards. So what I'm going to have to do is I'm going to have to change this 50 yards right here over to, now think about this, it's pretty easy, 150 feet. I mean, students, you know by now that 1 yard is 3 feet. So if you have 50 yards, 50 times 3 is 150. And if 1 yard equals 3 feet and you have 100 yards, then 100 times 3 would be 300 feet. So now I've totally changed the units of measurement for my soccer field. Now I'm saying the soccer field is 150 feet by 300 feet. Now, if I take 150 times 300, I'm going to get this for my area, 45,000 square feet. Now, do you see how I did that? I mean, now I know how many total square feet on this soccer field that I have to cover with fertilizer. I have to cover 45,000 square feet. So now I can take 550 square feet and divide that into my total area, and I will know how many bags of fertilizer I need. Now, if you do this correctly, you should get, let's see, I think you get 4,400. That leaves you with 100. And of course, you can use your calculator. I don't have a calculator with me, but you should get something like 81, and then you're left over with the remainder of 450. Now, obviously, you don't want to have a little section of your soccer field here that doesn't have any grass on it, okay? That doesn't have any fertilizer and there's no grass grown, okay? So you're not going to want to buy just 81 bags because you're not going to have enough. So you're going to have a little fertilizer left over, but you're going to have to buy 82 bags of fertilizer, okay? I hope that's made sense. If you need to, whether it be at home or in class, to back up the problem again and watch it again, that's totally fine, okay? But it's a good multi-step word problem thinking problem, all right, in which you're figuring out how much area you have of a certain figure so that you know how much of something to buy. Okay? All right. Hope this video has been a help to you. Call or email if you have any questions.